Welcome to BJK-NEET&MED. In this video, I am going to discuss about motion in a straight line, a topic of NEET physics. For a case, if a particle starts from rest, initial velocity is 0 and the constant acceleration, then Sm is the distance traveled in mth second. Sn is distance traveled in nth second. Then the acceleration equals to Sm minus Sn by m minus n. If we consider other case, like if the particle starts from rest with the constant acceleration, if it travels s in n seconds, Sn is distance traveled in nth second, then Sn by s equals to 2n minus 1 by n square. These two formulas are derived from the basic formulas which have been discussed earlier. In a case, if a bullet loses 1/nth of its velocity by passing through a plank, then the number of planks, such same type of planks required to stop the bullet, is n square by 2n minus 1, which is approximately equals to n by 2 plus 1. In other case, if the velocity of the body becomes 1/nth of the initial one, and if it has the after displacement of the x, then the further displacement such that the velocity of the body is will be 0 is y equals to x by n square minus 1. Let us consider a body with the graphical representation of velocity on the y-axis, time on the x-axis. If the body travels with the constant acceleration of alpha and attaining the maximum velocity, marking it as the Vmax, after that the body travels with the constant retardation with beta, and the initial time is t1 and next time is t2. In this case, Vmax equals to alpha beta t by alpha plus beta. T is t1 plus t2. S equals to alpha beta t square by 2 into alpha plus beta. Average velocity equals to Vmax by 2. If a body is thrown from a height h downwards, then the basic formulas will be V equals to U plus GT, because the gravitational force is always downwards. Both are in the same direction. A equals to plus G. Hence V equals to U plus AG, as it is thrown downward with the initial velocity U. Next formula will be V square minus U square equals to 2GH, as A is substituted with plus G. Then H equals to UT plus half GT square, because the displacement is substituted with H. The distance traveled by the body is nothing but the height of the tower from which the body is thrown down. Next, the last formula is Sn equals to U plus G by 2 into 2n minus 1. In next case, if the body is released freely with the initial velocity 0 from the height h, acceleration equals to plus g, because the direction of travel of the body and the gravitational force are in the same direction. Next, displacement equals to h. The initial formula is equals to V equals to gt, because U is 0. Next formula, H equals to half GT square. Next formula, V square equals to 2GH. Sn equals to G by 2 into 2n minus 1. Next case is vertically projected body. If the body is thrown vertically upward with the initial velocity u, if it attains the maximum height of h, the gravitational force will be directed downward, which is opposite to the motion of the body. Hence, the acceleration is minus g. The basic formulas becomes v equals to u minus gt, h equals to ut minus of gt square, v square minus u square equals to minus 2gh, sn equals to u minus g by 2 into 2n minus 1. Projection from top of tower. If the height of the tower is h, a object is projected vertically upward from the top of the tower, which attains the maximum height, and after that it travels the height till the height of the tower. After that it also travels the height of the tower to reach the ground. Hence, in the opposite direction, at the exact height of the tower from the ground, the initial velocity is same, but the directions are opposite. Hence, the velocity in the vector form, here it is minus u. If we consider only the case from travel of the object from here to here, h is equals to minus ut plus of gt square, because in this travel the object is traveling downward and the gravitational force is directed downward. Hence, a equals to plus g.